Good morning. I'm Meghna and today me and my groupmates are here to give a presentation on the topic improper input validation. First, let's get to know what input validation is. So the formal definition is that the input validation is a key process that ensures any data or input received by an application is tested against predefined rules or standards. These rules can include checking for length, type and format to make sure the input conforms to what the system is expecting. The main goal of input validation is to prevent malformed or harmful data from entering the system. By properly validating input, we can protect applications from various potential threats and maintain the integrity of the data. Coming to improper input validation, so it happens when an application doesn't properly check the data it receives from users. This can allow harmful data to slip through, leading to serious consequences. Example of improper input validations include SQL injection, cross-site scripting, denial of service attacks, buffer overflow, and remote code execution. It can also cause data integrity issues where bad data corrupts the database and create inconsistencies. Lastly, unexpected input can lead to application crashes, disrupting the user experience. Proper input validation is essential to keep the system secure and functioning correctly. Moving on to how can we identify improper inputs. So there are several indicators that improper input validation is happening, which indicates that improper input validation is happening. So for instance, if an application accepts inputs that exceed the allowed length or contain suspicious characters, it can lead to vulnerabilities. So another sign is when the application shows no error message after invalid input is entered, or the application behaves suspicious. So to detect these issues, we can manually review the code, looking for areas where the input validation might be weak. Additionally, we can perform positive testing, which ensures that the application does what it is implied for and performs each function as expected. And negative testing discovers diverse approaches to make the application crash and handle the crash effortlessly. Next, we have mitigations for preventing improper inputs. First is whitelisting, that only allows specific and approved inputs, while blacklisting blocks known bad inputs. Input sanitization is another important step where we can clean or modify inputs to remove harmful parts. Additionally, proper error handling ensures that the system responds safely to invalid input. Finally, using secure coding practices helps avoid these issues from the start, keeping applications safe from the attacks. Next, Sakshi will continue with the code example.
So we got an idea of what improper input validation is. So now let's understand it further using a code example. Here I'm going to discuss how this code is vulnerable and how the hacker can easily exploit it for personal gain. Let us understand the code and what it is doing. This code is designed to add items to a user's shopping basket. You can imagine this code is a part of a backend for an online shoe store, and a user visits the site, picks a pair of shoes, and decides to add them to their shopping cart. For the explanation of the code establishes a post endpoint for adding items to a shopping basket. It validates two parameters from the request, the item ID and the quantity. If either value is invalid, the server responds with a 500 error. Otherwise, it adds the item to the basket and returns a success response 200. This structure ensures that only valid items and quantities are added to the user shopping cart. Now coming to the vulnerabilities of this code, as I discussed in the last slide, that this code is validating inputs. But the problem is it is not validating the inputs semantically. It is only validating them syntactically. Let me give you a small explanation of what is syntactic validation and what is semantic validation. So syntactic validation focuses whether the input follows a predefined format, like verifying if the email contains an @ symbol. Whereas semantic validation focuses on if the meaning and the logic of the input makes sense, like a birth date. So your birth date can't be a future date, right? So you have to enter a birth date which makes sense. So that is what is a semantic validation. So here in this code, it does not check if the quantity entered is positive or not. If a negative quantity is added, it can be considered as a store credit. The hacker can easily manipulate the system for receiving credits instead of charges. So how can this code be fixed? There are two things which can be done in this code to fix this vulnerability. First, we can add an extra check to ensure if the quantity being given is positive or not. This will ensure no one can enter a negative or a zero value. Other way of preventing the vulnerability is adding the between function, where the 1 is kept as a valid quantity and infinity allows only a positive integer. This was a very basic code to gain an understanding that how improper input validation can give hackers a chance to exploit the website. Now Sandhya will continue with another example.
Moving on to the second code example, in this Python example, we use a function which is printing the contents of a file and the file name is input through the console. So this method uses shell commands to print the contents of the file. This method takes on one input parameter which is provided as a command line argument when the program is executed. As you can see in the main method, the command line parameter is not validated in any manner. It is just input from the console and passed on as a parameter to the function. This can cause problems as we will see in the next slide. The lack of validation in the code can be exploited by malicious users. For example, any shell command can be input through the command line in the name of a file name, which can then be executed by the vulnerable function. Shell commands such as rm, which are used to remove files from a directory, can be used to delete any important files. Syntactically, the input is a string and can be accepted. But semantically, we can see that a shell command is being accepted as a file name, which should not technically be happening. So how can this be fixed? To fix this vulnerability, we can add another method which validates the input that is taken in through the command line. Basic checks can be added if the input string contains a specific file extension of length 2 to 4. Another can be a check for absence of spaces or any other special characters that cannot be present in a file name. Lastly, we can also check if the file actually exists in the system before printing its contents. If any of these checks fail, then we can ensure that the command is not executed on the shell. This way, we can ensure that the input provided by the user is properly validated. Next, Monica will continue with the next example.
Coming to the code example 3, here the code is about discount and price. Now coming to the function, here we use applied discount, which calculates the final price of a product after applying a discount. But here in this code there are several issues related to improper input validation, makes it vulnerable to errors. So coming to the first error, no validation on input. The price and discount percentage values are obtained directly from user input without having any validation. If the user inputs non-numeric values such as strings like ABC, the program will attempt to convert these inputs to floats, which will raise a value error exception, causing the program to crash. And the second one is improper handling of negative prices. The code doesn't check whether the price entered by the user is a positive number or not. Negative prices are unrealistic and should be disallowed. The function will accept negative values and proceed with the calculation, leading to incorrect results. Coming to the third error, improper handling of discount percentages. So here the code doesn't validate the discount percentage either. It allows values outside the valid range. For example, values greater than 100%, or we can give the value less than 0% to be entered. resulting incorrect final prices. For example, a discount of 150% or minus 10% is not valid in a real world scenario, but the function doesn't prevent such inputs. Coming to the non-numeric input handling, since the program converts the user inputs to floats without checking if there are valid numeric values or not, any non-numeric input will lead to an exception. This is problematic in user-facing applications as it will interrupt the user experience and crash the program. Coming to the vulnerabilities, here we can see what are the affected components and consequences of the code. First of all, it is input handling vulnerabilities. The first issue is how the lack of input validation can cause the program to crash when non-numeric input is provided. For example, if a user enters a string like ABC instead of a valid numeric value, the program will raise a value error due to the improper handling of input conversion. And the second one, error handling. It's the absence of proper error handling mechanisms like try except block. Without this, any invalid input directly crashes the program, which leads to a poor user experience. So error handling would allow the program to gracefully handle errors and provide useful feedback to the user instead of terminating. Coming to the financial implications, incorrect price calculations due to improper validation can have like real world financial consequences. If the system accepts a unrealistic discount percentage like negative or more than 100%, it could generate invoices with incorrect amounts. This could result in either financial losses for the business or overcharging the customer, leading to trust issues. And coming to the security vulnerabilities, allowing the extreme values for discounts such as percentages over 100% can introduce security vulnerabilities. If unchecked, these could be exploited to manipulate the system. And also poor user experience, all these issues contribute to a poor user experience. Users may find the system difficult to use or unable to use if it crashes the incorrect outputs. In this slide, we can see how to fix the vulnerability of the code. This code addresses a vulnerability related to improper input validation, which calculates a discount on a given price. The first one is implementing input validation. The first step in fixing the vulnerability is to ensure that both the price and the discount percentage are validated. The price must be a positive number and the discount percentage should fall within the acceptable range of 0 to 100. The validation checks in the apply discount function handle these conditions. If the price is less than or equal to 0, the function returns an error message, price must be greater than 0. If the discount percentage is less than 0 or greater than 100, the function returns an error message, discount percentage must be between 0 and 100. So like this, it will prevent invalid data from being processed. And the second one is using try except for error handling. The try section, the user is prompted to input the price and discount percentage. The float function is used to convert these inputs into numbers. For example, non-numeric values. A value error will be raised. The except block catches this specific error and provides a user-friendly message like please enter valid numbers for price and discount. This ensures the program doesn't crash and instead handles the invalid input. And also coming to the third vulnerability fix, user-friendly error messages. Finally, user-friendly error messages by providing specific feedback such as informing the user that the price must be greater than 0 or the discount percentage must be between 0 and 100. Users can easily correct their mistakes. Additionally, the message for invalid data types ensures users are aware when their input is not recognized as a valid number. Hope you understand how this improper valid input validation works. Thank you.